we're going to use integration by parts, which is uv minus the integral of v du dx. So now let's assign values. Let's make u the inverse of cos x. So u equals cos minus 1 x. So we now need to differentiate that to get du dx. And the differential of this is minus 1 all over the square root of 1 minus x squared. If you don't know how to do this, I've got an entire video on how to differentiate the inverses of sine, cos and tan. I'll probably link them in the description. We now have dv, which equals dx, and we can then integrate these, so you're going to get v equals x. We can now substitute this into here, so we've got uv, which is uv, so you're going to get x cos minus 1x minus the integral of v du dx, so that's x du dx, which is going to be x to the minus 1 over the square root of 1 minus x squared dx. We can now ignore this part and just integrate this again. So you're going to get the integral of basically x over 1 minus x squared, so the square root of it. So if we now just ignore this minus and pull it out, that's then going to become a positive. So let's let 1 minus x squared equal u. So 1 minus x squared. And that means du over dx is going to be minus 2x. But we can make du equal minus 2x dx. I've just pulled the dx to the other side, which is pretty straightforward. So therefore, you're going to have minus a half and the integral of u minus 1 over 2 du. So I've converted this square root into its power, which is a half. Because it's in the denominator, it's minus a half. So you're then going to then have minus a half multiplied by 2 u to the half, which is then going to obviously mean that these are going to cancel out, and you're going to get 1 minus x squared. So now let's bring it all together. We've found out this part and we've integrated this part. So the total integration of the inverse of cos is going to be x cos minus 1 x minus the square root of 1 minus x squared plus c. And you're done.